Hey, what's up, guys? Chung here. So, so this time let's take a look at another LeetCode problem here. Number 1216, valid palindrome 3. So you're given a string and an integer k. Find out if the given strings is a k palindrome or not. So a string is a k palindrome if it can be transformed into a valid palindrome by removing at most k characters from it. So I'm assuming you guys know what a palindrome is, right? So a palindrome is like this. A itself is a palindrome. AA is also a palindrome. And BAAB is also a palindrome. And ABA is also a palindrome, right? So the difference here is asking you to try to if you can convert a palindrome into a non-palindrome string into a palindrome string by removing at most k characters, right? So how do we solve this problem, right? So obviously this one we can use like dynamic programming, DP, right? Basically, we're gonna have like a DP, DP INJ, right? So DPIJ means the from I to J, what's the from for the substring I and J, what's the minimum string we need to remove in order to make it as a valid palindrome. Okay, so and then how can we do this, right? So if you guys remember how can we solve the there was a like a medium problem like the valid palindrome. So the way how can we check if it's a string is a valid palindrome or not, right? We use a DP, right? We compare if the current string basically we check if the current I and J the string if the string I and J, right? So usually with this kind of like DP problems, and we have like start and end range for the substring, we always check if the start and end they are the same or not, right? So in this case, if they are the same, then okay, by adding, which means we don't care about the start and end, right? We can simply check dp I plus one, right, and j minus one, right? Because if this a B and B here, right? And there's like a substring in between, right? This is I, this is J, right? So if the start and this, if the current I and J are the same, right? Then whatever in between here is I plus one to J minus one, right? So whatever in between it's gonna be the same value we have for the DP, right? Because by adding this one, we're not changing anything, right? It's also if the internal one, if the substring internal from I plus one to J minus one is a valid palindrome, by adding like the same characters on both sides, it's also a palindrome, right? Basically, that's how we solve this like the original valid palindrome problem. And so the difference here is that not only we need to check if this one is a valid or not, right? So and else, right? Else, right? If this is a valid palindrome, basically we're in our case, it means that sorry, if this si equals sj, it means that we're not going to sorry from dp I plus one to I to j minus one, we don't need to remove any actual character, right? Because it's the same, right? Else, right? What if it's not the same, right? If it's not the same, which means we need to remove one character, right? To get to the and how can we remove it? We can either remove uh, the left the I the character I or the character J, right? That's why we need to do a minimum basically, right? So else is going to be the minimum. So we can remove I. If we remove I, it's going to be a dp I plus 1, right, to J, right? If we remove J, it's going to be dp I J minus 1, okay? Why? Because if we remove I here, right, so we're relying on starting from here to the end, right? So whatever, if this one is a substring or not. If it is a substring, then we know, sorry, what am I saying? So basically, if we remove the i's, let's say we have a c's here, right? Then we are relying on the dp I plus 1 to j to tell us how many k do we need to remove in order to make this dp ij a valid palindrome, right? And another way of getting to the current state is we can get from by removing the c's here, by removing the last one, which will be the dpi j minus 1, right? No matter how we get this one here, no matter what's the value, how many, remember that ij equals to how many, the minimum k we need, right? So no matter which one is smaller, we get the smaller one and then we plus 1. Because since it's different, we know even though it's 3 and 5, right? With this, with the minimum is 3, we still need to plus 1 to because the current I and J are different. So yeah, and in the end, we simply return the dp what 1 and an n, right? That basically tells us from first from the first element, from the first character to the last character, which means it's our original string, right? How many case we need at least to make it a valid palindrome, and then we just compare it with the k, right? If it's smaller than the k, then it's true. Otherwise, false. All right, cool. So I think that's it for this problem. Let's try to code this thing here. Basically, we're getting the n here, right? As and we're creating a 2D array here, right? And it's going to be 0 at the beginning, right? We set it to 0, right? It's going to be n. So since we're going to do like a I minus 1, j minus 1, it's just for we make sure it won't be out of the bound, which won't go over 0. We'll just initiate with n plus 1 length. So okay, and then so basically for I in range. So since we're trying to get, so the DPI in my case, it means the from I to J, right? So in order to get from I to J, I need to, for the first index, I need to uh, basically traverse it from end to the beginning. That's why that, and every time when we have a start, we just traverse everything back. Right. You can also do it from the beginning to end, but in my case, I just do it from end, from the end to the start. Right. So basically, it's going to be n plus 1, and stop is 0, right? Because the stop is 1 actually. So for j in range, and it's going to be from I, right, to n plus 1, right? And then we check if the n if si minus 1 equals to sj minus 1, right? Since we're starting from 1 here, uh, uh, until 1, right? So this I is the length basically, and so that's why we're using like I minus 1 because the length is n plus 1. That's why we use we minus 1 to get the correct string here. So if this thing is the same, right? Like I said, what does the dpij means, right? It equals to 0, right? If it's 0, it means that we don't need, sorry. So when would it be 0, right? 0 means it's a valid string and does not need anything. Uh, if j minus I is less than 2, right? Else dp I plus 1 j j minus 1, right? So basically this 0 here is a little bit kind of like a redundant, but I just make it the 0 here. Basically, as long if they're the same and as the difference is less than 2, this basically this covers cases for one string and the 2 is the same. So basically this one covers this two. So basically it tells us, okay, so for 1 and the two array strings, if they are the same, and then we simply set this one to 0, which means we need 0, we need to remove 0 strings, 0 characters to make it a valid palindrome, right? Otherwise, otherwise it's more than 3, then it's rely on the sub string, right, to tell us how many Ks we need to remove, right? So that's that else, right? Else what? Else we do a dp, right? Like I said, we need either remove the left one or the right one, right? So that's why we need to do minimum dp I minus 1 j. This is how, sorry, this is we remove the left one, and then dp I j plus 1, right? Mm, yeah, n plus 1. Okay, that's how we if it's that's how we get this dp value if they are not the same. We either remove the left one or the right one. Sorry, the right one is minus 1, right? And then in the end, we simply check if the dp 1 to n, right, is smaller or equal than k, right? So true, let's just run it. Yeah, it's passed. So yeah, it's a pretty straightforward dynamic programming problem here, and just a 2D loop here. So it's obvious, right? Time. Let's take a look at time and space complexity. It's obvious nested loop here. So the time is O n square, right? And how about the space, right? Space same, right? O n square because it's a 2D array here list. Um, cool. I think that's it for this problem. Yeah, basically a little bit variations from the traditional valid palindrome. In this case, we'll be calculating the current minimum removed characters for each of the state here. And in the end, we simply compare the final result for the whole string. Cool. Okay, I think that's it for this problem. Thank you so much for watching the videos. And yeah, I'll be seeing you guys soon. Bye bye.